This is the video on chemical bonding. All right, so just remember in the weekly review video, there will be two codes. One will be written code on the screen, and the other code will be said by myself. Each code will be 3 numbers. You will need all the codes in order to move on with the homework assignment. So when you're looking at these slides or looking at this video, just write what is in green. Put that information in your notebook. That's like the big ideas, and you can sort of bullet these ideas. So this is the weekly review video, the written code. I would recommend writing this down somewhere. So here's the original question here. What is an ionic bond? So I put sodium chloride there, which is just regular table salt, which is held together by an ionic bond. So ionic bonds are formed from the transfer, giving or taking of valence electrons. This is only between metals and nonmetals. So here are the steps for ionic bonding. Atoms turn into ions because atoms want their outermost orbital filled with 8 valence electrons or 0. Metals will lose their electrons while nonmetals will gain their electrons. And oppositely charged ions are attracted to each other electrostatically, and they stick together like magnets. So if we look at this periodic table, if I've got atoms that are bonding, if one's a metal and one's a nonmetal, so one's like this blue from the blue and one's from the yellow, including hydrogen, it's going to be an ionic bond. So what do I mean by that? So let's do an example problem. Let's do sodium and chlorine. You can see there's a little graphic down here. Well, sodium it's going to lose electrons because it has one valence electron. It's going to give up that one valence electron to become a positive cation. It's going to become sodium with one positive charge. Now, chlorine is going to gain electrons. If you look at chlorine, it is in group 17, meaning it has 7 valence electrons, so it's going to gain 1 valence electron to get up to 8, and that means it's going to lose an electron to become a negative anion. It's going to become like the chlorine with a 1 negative charge. The positive cation and negative anion will form an ionic bond. So if you look here, what's happening is that sodium atom gives up an electron to become a sodium ion with 1 positive charge. Chlorine takes that 1 electron, which means it has a negative charge. And because I've got a positive and a negative ion, well, they're going to stick together like magnets. That is an ionic bond. It's basically turning them into magnets. So let's look at another example problem. Let's look at magnesium and oxygen. So now magnesium, it's going to lose 2 electrons, and it's going to have a positive 2 charge, right? Because it is in group 2, it wants to get down to 0. It's going to give up 2 electrons to have magnesium with a positive charge, that magnesium ion. Now, oxygen, if we look at that, oxygen has 6 valence electrons, so it's going to gain 2 electrons. It's going to gain 2 electrons to become a negative anion, and it's going to become 2 negative with a negative charge. So the positive cation and negative anion will form an ionic bond. So in this one, now I've got a positive 2 charge and a negative 2 charge. Well, and they're going to form magnesium oxide. So I have one of each because I need that compound to be neutral. So you see magnesium oxide. Now, putting ions together, right? And let's take a look at the crisscross method. So sometimes it works out perfectly. Hey, my cation has a 1 positive charge and my anion has 1 negative charge, or my cation has 2 positive charges and my anion has 2 negative charges. So I only need one of each to get a neutral compound. But there is something where if those don't match, we can use the crisscross method. So if we look at this, like lithium oxide, lithium is in group 1, so it's going to give up 1 valence electron to become a positive 1 cation. Oxygen is in group 16, so it has 6 valence electrons, and it's going to gain 2 electrons to have 2 negative charges. Well, you probably can just look at this and say, well, if I need a neutral compound, so the positives and negatives have to add up to 0, well, I'm going to need 2 lithiums. So it might just be obvious on this one, but there can be some trickier ones here. So with this 1 charge, you just look at the number, tells me how many oxygens I need. This 2 on the oxygen tell me how many lithiums I need. So it's just this crisscross method. So let's just take a look at some examples, right? So let's look at magnesium and chlorine. So this positive 2 charge tells me, well, I need 2 chlorines. This 1 negative charge on chlorine tells me I need 1 magnesium. So it's going to be magnesium. I do not write the subscript of 1, and chlorine 2. That's magnesium chloride. Aluminum and iodine. So if I look at this, now I've got a +3 charge on aluminum and a -1 charge on iodine. Well, the crisscross method tells me, well, I'm going to need one aluminum, and if I take this 3, I'm going to need 3 iodine. So it's aluminum, iodide, and it's 3 iodines, right? I'm going to need that. Calcium and phosphorus. So it might be obvious up to this point. Well, obviously, I'm going to need 3 negative charges to balance out a +3 charges. Obviously, I'm going to need 2 negative charges to balance out a +2 charge. But let's take a look at a scenario where I've got calcium with a +2 charge and phosphorus with with 3 negative charges. Well, if I use the crisscross method, this the 3 negative tells me I'm going to need 3 calciums. And then the 2 positive charge, that's going to tell me I'm going to need 2 phosphorus. So I get Ca3P2, right? So that's how the crisscross method can come into play. So 3 times 2 positive charges, that's +6, and 2 times 3 negative charges is -6. So it balances out to be that neutral compound. So here's how we name simple ionic compounds. Cations are named by saying the element and adding the word ion. So like sodium becomes a sodium ion, magnesium becomes a magnesium ion. Now, anions are named by dropping the ending off the element name and adding IDE or ide. So fluorine becomes fluoride. Let's see, oxygen becomes oxide, nitrogen becomes nitride. Now, when you're just saying the word of a compound, you just say the cation, you just say the name of the element. Then the anion, you just say the word of the ion, right? So it'd be like sodium fluoride, sodium oxide, sodium nitride, magnesium fluoride, magnesium oxide. It doesn't matter how many of each you have. So let's just go ahead and get some practice, right? So I've got calcium and 2 fluorines. Well, calcium fluoride. It doesn't matter how many of each you have, right? You just say the name of the cation, and then you say the name of the name of the anion, but you drop the ending and add IDE. This one is potassium sulfide. I've got lithium bromide, potassium oxide, calcium phosphide. So notice it does not matter what you say. Like it's the same process for all of them, right? Naming simple ions is very easy. So in order to do this, we got practice with this magnetic ionic compound where we were making little shapes on the magnetic boards. But you can see here there's a lot of practice where using the crisscross method to figure out how many of each of those different atoms that you need and naming them, right? So naming them should be fairly easy because you're just saying the name of the cation, then the anion, you're dropping the last part and adding ide. Now, let's talk about another type of bond. What is a covalent bond? Now, covalent bonding, those are formed from the sharing of valence electrons. This is only between nonmetals. So co equals working together. Valent means valence electrons. So covalent bonds are the sharing of valence electrons. So if you look here, if I've got 2 nonmetals bonding together, they're going to share those electrons. No electrons are being given up or taken. But if I have, and you have to remember hydrogen over here is a nonmetal as well. So if I'm giving up those oxygen, or if I'm not giving up those any of those electrons, what's happening is they are sharing them. So if you look at water right here, H2O, notice that, well, oxygen has 6 valence electrons, hydrogen has 1. They're going to share that electron to form a pair. So oxygen has 8, hydrogen has 2 because it only fills that first orbital. So this is how like covalent bonds are formed, and it's only between nonmetals. So naming is a little bit different of covalent compounds. So these are the steps for naming compounds with covalent bonds. So you start with the element's first name. The second element ends in IDE. Same process as the ionic bonds, but there is an extra step. You use the prefixes to show how many atoms are present. Do not use mono for the first element. So you can see here, this is the prefix chart over here, the number of atoms and covalent prefix. So you could have something like carbon monoxide. So you've got a 1 carbon atom, 1 oxygen atom, and notice that, well, I don't say mono for carbon, even though I only have 1. It's just implied, and then I have to say monoxide because they share electrons. You could have single bonds, double bonds, triple bonds, so you could have carbon dioxide, like what we breathe out. So notice di is 2. So I've got carbon dioxide. You could also have carbon trioxide, carbon tetroxide, carbon pentoxide. So let's go ahead and get some practice naming covalent compounds. So I've got 1 carbon, 2 sulfurs. This is carbon disulfide. So remember, di means 2. This one I've got 2 of that first element. So this one's dicarbon tetrabromide because I've got 2 carbons for those bromines. So I've got tetrabromide. The next one is, well, dinitrogen monoxide. I've got 2 nitrogens, 1 oxygen. This one, well, I've got 1 carbon, 4 fluorines. This is carbon tetrafluoride. 1 phosphorus, 3 chlorine. So I've got phosphorus tetrachloride. This one, well, I've got 4 nitrogens, so tetranitrogen, 5 oxygens, tetranitrogen pentoxide. So in this one, because you can have covalent bonds, they're sharing those atoms. You're going to need to use those prefixes to determine how many of each that you have. So here's another question. What is a metallic bond? So this is the last type of bond we're talking about. Metallic bonding is when cations are held together by a delocalized sea of valence electrons. This is only between metals, right? And it's mostly in those transition metals. All of the atoms in a piece of metal share these electrons, and they can flow freely through the whole material. So it's not so much they're giving their electrons away to fill a full valence shell, or take a valence electron to fill a shell to another one. They're not taking them. They're not sharing them either, like saying, hey, we're going to share these. What's happening is that because those metals, that's when the d orbitals come into play. But those valence electrons are going to be free flowing. They're flowing around. They're going to be shared by every one of those cations, and that's what holds them together. So think about like a block of iron. Think about a block of gold or silver. That's what's holding them together. It's the metallic bond. So at this time, I'll go ahead and give you the verbal code. The verbal code is 468. I say that again. The verbal code is 468. So in order to put all of this together, we did this identifying chemical bonds class activity where there were 2 different ones. Number 1, you had to identify what type of bond it was, and then they give you the compound name. And then the next part, what you had to do is you had to identify the bond type and then write the compound formula. So sort of puts it all together. And to identify the bond type, you have to look at the elements there and determine whether it's a metal and a non-metal, non-metals only, or metals only. So once again, there is too much unknown in the universe to take a break from learning. Get out there and question everything.